Good day, everyone. This is Instructor Ella speaking, and by God's grace, I'm chanced to be teaching this course, Essentials of Programming. But before I start, I would like to give thanks to God for this privilege to be here, for the privilege to be able to take this course, for the knowledge and the understanding bestowed upon me. I pray that for as many of you that will be watching this course and listening to me, I pray God will bestow wisdom upon you as well, and may you understand this course as we continue. So without wasting further time, let's go to the main focus of today. Our main focus of today is what? Extensions of programming. Welcome to the world of programming, people. I am your instructor, Stella Diamond. So we're going to be looking at our course content. Our course content, we have what is programming, we have types of programming language, we have programming concepts, we have programming paradigms, we have web development, we have career paths in programming, we have getting started, conclusion, and additional resources. I'm going to be giving you guys some additional resources that will help you in your career path towards programming. I will tell you some things, some books to read, some online websites to visit that will help you in your programming career, that will help you more focused and will teach you more and give you more ideas. So without wasting much of our time, let's dive in. Now, firstly, what is programming? We are studying programming. What is programming? Programming is the process of writing instructions that a computer can understand and execute. In life today, for us to be able to do anything, we need instruction. If our mother wants to send us somewhere, she will say, come here, go there. That instruction is what we follow. So same applies with programming. Programming is what the process of writing instruction that a computer can understand and execute. So if we're looking at the keywords here, the keywords of this, firstly, let me get my highlighter, sorry for this cutting. Let's take a rectangle shape. So let's look at the keywords of this programming. It says what? Writing instructions that the computer can understand and execute. So execute is also a keyword, because if they don't execute it, we can't get results. So these are our three keywords: writing instructions that the computer can understand and what execute. If the computer does not understand it, there's nothing it would execute, or there's nothing it would do. So if we look at this diagram at our left hand side, we will see that these are a set of instructions. For those that are new to programming, this is a flow chart. We can also use this method to write instruction. We can also use it to write instruction that the computer can understand. The oval shape in the flow chart means start or stop. The diamond shape that you're seeing in the flow chart means decision. And this rectangle shape you're seeing here is maybe the task you are to do. So now let's start. This is the issue here. Lamp doesn't work. Lamp doesn't work. So we the programmers now were to ask the computer, is the lamp plugged in? That's an instruction we're asking it. We're giving it that instruction. Is the lamp plugged in? So the computer gives us an output saying what? No, it is not plugged in. So we'll give it back another instruction that was plug in the lamp. But coming down here, while this arrow is coming down, if the lamp is, after asking him, is the lamp plugged in, we'll now ask, after plugging in the lamp and it doesn't still bring out light, we'll now ask him, is the lamp burnt out? If he says yes, we'll say what? Replace bulb. But if it says no, tell it buy new lamp. That means the lamp is spoiled. I don't know if you get that part. If the lamp is not plugged in and we asked it to plug in the lamp, yet the lamp is still not on, so we asked it again, is the lamp burnt out? If it says yes, that means a burnt lamp can be replaced. We'll tell it to replace the bulb. But coming down here, if we ask it, is the bulb burnt out, and it says no, we'll tell it, okay, buy us a new lamp, simply because this lamp is no longer good again. So without wasting further time, let's move on to the next slide. So we have types of programming language. Types of programming languages. We have different types of programming language. We have the high-level languages, we have the low-level language, and we have the scripting languages. So high-level languages are languages that are easy to write, easy to read for humans. for human being like you and I, we can read high-level languages. Why the computer can't really read it, they can't really understand it, except there is an interpreter to convert it into a machine language. But we programmers can understand, we can read, and we can write high-level languages. And why is it that we can read it and write it? Is because high-level language is written in human-like languages, that is in English. It is written in English, human-like languages. So examples of high-level language, we have Python, we have Java, we have C++, we have C#, we have other types of high-level languages. We also have Perl. Perl is also an high-level language. So coming down to low-level language are languages that we cannot read and we cannot write it. Though it is possible to read and write for those that are actually studying it as a course. So it is possible, but it is difficult, unlike the high-level language that is very easy for even a beginner programmer to be able to read and understand it. So the low-level language are machine languages. They are written in like binary code. Machine languages, it is easy for the computer to read it and understand it and execute it, while we programmers need interpreter to interpret it to what a high-level language for us to be able to understand it. Why it is called low-level language is that it is closer to the computer level and far from programmers level. We can't easily understand it or read it. So examples of low-level language, we have the assembly language and we have the machine code language. Moving further to scripting languages. Scripting languages are languages that we use to perform specific tasks. Examples are JavaScript and PHP. Let me explain a bit more on that scripting language. Like if we want to create a website that transfers money. Yes, the JavaScript code we're going to write, the lines of code we're going to write is going to be quite different from if we want to create a website of communication, like a website for Facebook. The JavaScript lines of code there are different from the JavaScript lines of code that are used in OP. And why is it like that? Because scripting languages are used for specific tasks. Facebook is used for communication. OP is used for transferring. So the scripting language used in both websites would be different, but the same name, like it is the same scripting language, JavaScript, but different lines of code. They can use PHP as well, but it can have the same type of scripting language but different lines of code, because scripting language is used to perform specific tasks only. So looking at my diagram here, we have types of programming language. We have the ASP, we have the C#, we have C++, we have HTML, we have CSS, we have JavaScript, we have PHP, we have Java, we have Perl, we have SQL, we have Python, we have Ruby, and so on and so forth. So many of you might be wondering, what is ASP? ASP is active server pages. It's a server page, yes. So it's under scripting and under high level. Though it does not really belong to one, but it's one of a server language. We have C#. C# is an high level language because it is written in what English like type of program. It is easy to read by the programmers, even by users. It is easy to read and understand. We have C# is an high level language. We have HTML, CSS, and JavaScript. HTML is hypertext makeup language. CSS is cascading style sheet. JS is JavaScript. Though these three are not really belonging to any programming language, but these three makes up front end. Front end. What is front end? Front end is is a view users see when they go to a website. When you go to a website, all this home page, all these things you see in the website is called front end. Later on, we'll talk more about front end. Just stay tuned and wait for my next video that will be on front end. So let's come back to what we are doing here. So HTML, CSS, and JavaScript are the three major languages that makes up the front end. They don't really belong to any programming language, but they're also considered what a language. So we have PHP, personal hypertext preprocessor, we have Java, we have Perl, we have SQL, structured query language. Though it's not really belonging to any programming language because it is a query language, but we can still use it because it is used to what, store and receive information, store and receive data. It mostly works with relational database, so it is not really considered a language, but it is a language. It's not really considered a programming language, but it is a language used. We have Python belonging to the high level language. We have Ruby belonging to the scripting, Perl to the high level language, Java high level language, PHP scripting language, JavaScript, CSS, and hypertext markup language, HTML. Are not really programming language. C++ belongs to the high level language. C# high level language. ASP is a server page, active server page. So let's move on to the next slide. Programming concepts. Programming concepts. So we have variables, we have data types, we have control structure, if and else, and loop. Then we have functions. So these programming concepts are things you mostly see in programming, things you can't do without while you are coding, while you are programming, while you are learning programming as well. You can't do without these things. That's why they are called the programming concepts. So what is variables? Variables is defined as the memory location that hold value. Defined as the memory location that holds value. So if you want to put any value to anything, you can't just go to your code now and just write 20. We won't understand what the 20 is. Are you saying age is 20? Are you saying money is 20? Are you saying time is 20? We won't understand. But with the help of variables, which is the memory location that holds value, we would be able to understand, okay, this is what you're trying to say. This is what you're trying to say. Let's explain the concept before we dive into the diagram. Data types tells us the type of value a variable can hold. We have different types of data type. So without this data type, we can't know the type of values our variables is to hold. So we have different type of data type. We have the int, which tells us that the variable is to hold whole numbers. We have the floats, which tells us that the variable is to hold decimal numbers. We have the char, which tells us that the variable is to hold a single character. That is either A, B, C. We have string, which tells us that the variable is to hold a text, either short or long text. We have boolean, which is true or false. The variable is to hold a value of true or false. Then we have control structure. Control structure helps us to control the flow and execution of a program. If and else is a control structures that helps us to control the flow of execution of program based on conditions. Let me give you a live example of if and else statements. If and else, okay, let's say assume you're throwing a party, a birthday party, and only people within the age range of 18 to 20 are to attend your birthday party, and let's say they are to register online for your birthday party, so you know the number of people that will be coming for your party. Now you're going to write a line of code. You would write that if age is equals to 18 to 20, print you are invited, else print you are too young or you are too old. I don't really know if you get that scenario. At this point, I would advise that if you are not with notebook, you should get a notebook for yourself. Write down this example so it will make better sense to you. I will take it one more time. If you're throwing a birthday party and you want only those within the age range of 18 to 20 to attend your birthday party, using a line of code, you can just write if age is equals to 18 to 20, print you are invited, else print out too young or too old. That means they're either greater than the age of 18 to 20 or they are below the age of 18 to 20. So with the help of if and else statement, with the help of if and else control structure, we can control the flow of program based on conditions. Then loops. Loops helps us repeat a block of code for a number of iterations. If we want to write x 10 times, on our programming language, if we want to write x 10 times, we are going to write print x, print x, print x. We're going to write that print x in 10 lines before our output can give us x in 10 places. But with the help of loops, we can easily write a line of code, then it will help us repeat our line of code for our possible number of iteration, the specific number of iteration that we want it to repeat for. Like, loops have different types. We have a for loop, we have a while loop, and we have do while loop. So we can use either a for loop, a while loop, or a do while loop to carry out this operation. So if you want to use a for loop, you would just write if I equals to 0, then you write I plus plus, you write print I. It's just like that. Then to repeat I for you in 10 times, in 10 lines. So that is just what loop is for. You write a specific line of code, then it will repeat it for you for your specific numbers of iterations, rather than what writing it single-handedly, rather than writing it manually in your IDE or your text editor, rather than writing it line by line, print x for me 10 times, print x, print x, print x, print x. That will take a lot of time. That will make your program, that will make your code large, broad, and really not that unique or easy to read. But with the help of loops, you just write a single line of code, then your output will help you repeat that language, that thing you want it to repeat for a specific number of iteration, for the specific number of time. So let's go to function. Function is a block of functions is a block of what code that performs what specific task, takes input, returns output, and can be reused. Functions can be reused. So without wasting much of our time, let's look at the diagram at our left hand side. Variables in C++. So the language they are using, this example now is from C++. Other languages are also the same thing. The data types in C++ is also the data type in Python, the data type in Java. Int is for whole numbers, float for decimal, char for single text, while string for text, boolean for true or false. So that was much about it. Look at this our example given. Int age is equals to 20. Everybody knows that this 20 is a value. So now firstly, this int age that was given here, this int is telling us what type of value this age we hold. So since our data type given was int, our value must be an whole number. If you use a decimal point here after using int as your data type, you will have an error message. But if you use int for this, you have a successful execution of program. So this variable name age is telling us now that when you want to search your program, if you can't just go there now and like, what did I use and hold that 20 of a thing? No. You will remember that, okay, use a variable name age, you search for age and the name would come out. Or when you want to print out your output in your programming language in your website using your IDE or your text editor, you write print age. So your program cannot return an error message because it knows what the age is. It will go to your code, your programs, search age, and it will return the value for you. But if age wasn't used to hold the value 20, if you write print age, it will return back a error message for you saying there is nothing like age in my code. So without wasting much of our time, let's go on to the next slide. I hope you're understanding. I hope you're enjoying this tutorial class. Stay tuned as we move to the next slide. Now we have programming tools. So under our programming tools, we're going to be talking about different types of tools, different types of ways we can write our programs. For those that are watching, if you have a notepad, a subline text, then you are good to go. You can start writing program even through your phone. You can start writing your program. If you have your laptop, you can also start writing your program. So programming tools, we have text editors, we have integrated development environment, IDE. We also have version control system. So under text editor, we have the notepad, we have the subline text. Then under integrated development, we have the IDEs. That's example of IDEs. We have the Eclipse, we have Visual Studio Code, and we have PyCharm. Then Under version control system, we have the Git and we have the SVN. In case you're wondering, SVN means subversion. So these tools enable us to write our code, run them successfully, and have our desired outputs. So looking at the diagram on my left hand side, it's a lot of programming tools we can use. We have the Android Studio, we have Eclipse, I've mentioned that earlier. We have the Xcode, we have the Visual Studio, I've mentioned that earlier. We have Atom, we have IntelliJ, we have R Studio, we have PyCharm, we have Sublime Text, I've mentioned that earlier. We have NetBeans, and okay, Visual Studio Code repeated itself twice. So these are the tools we can use to write our program. So try getting one of these tools to enable you to start your program career very soon and quickly. Moving on to programming paradigms. Firstly, what is paradigms? Paradigm refers to the philosophy or style of what? Writing a program. So under programming paradigms, we have two major programming paradigms, which is the imperative and the declarative. Looking at the diagram on my left, you will see that clearly that we have just two, imperative and declarative, while others are underneath each other. So coming over here, we would explain what the object-oriented programming is. What the object-oriented programming (OOP) is. So what object-oriented programming, this helps us. This programming language are based on objects because it's an object-oriented programming, so it is based on objects. We write the programming code based on objects. And what are objects? Objects is an instance of a class. What is a class? Class is a blueprint of an object. So we write our code based on objects. So we have imperative programming. What is imperative programming? Imperative programming, this focuses on how to achieve results. These are programming paradigms that focuses on how to achieve a result. We have functional programming. These are programming that consist of pure functions and recursions. Pure function in the sense that what you give in, the input you give in is the input you receive. So functions programming is a programming that consists of pure functions. Then we have declarative programming. Declarative programming focuses on what results to achieve rather than how to achieve it. They just want to know, okay, what result am I going to achieve? What do I stand to get? Rather than how to do it. Why imperative focuses on how to do it. They don't care about the result they get, but how they do it perfectly is what is their major focus. So looking at the diagram on my left hand side, you will see that the major two programming is the imperative and the declarative. The one that focuses on how to do things and the one that focuses on how to do things and the one that focuses on what results they will get. This is on how to do things, and this other one focuses on what results they will get. So without wasting much of our time, let's move on to the next slide. I hope you're enjoying this program. Please stay tuned. Now, web development. A lot of people have heard web development. What is web development? Web development. Okay, to successfully be a web developer, you have to be good in what's your front-end development, you have to be good in back-end development, framework, and libraries. With the help of these three, you can also become a full-stack developer, and you can develop both front-end and back-end. So what is a front-end? What are front-end development? Front-end development are the sites you see first when you go into a website. That welcome page, that home page, that things you see and interact with is the front end. The back end are the things that carries out the operations. We can't see them. Like when you send message, when you send message to that your friend, it's not, some of you might be wondering, how is it done? It's the back end and the scripting language that is doing all those things for us. Then we also have the framework and library. Framework and library are what? Collections of pre-written code. So now to successfully create a front end, we need to be good in HTML, hypertext markup language. We need to be good in CSS, cascading style sheet, and we have to be good in JavaScript. Then to successfully be a back-end developer, we have to be good in server-side languages. You have to be good in Python as well. You have to be good in Java. You have to be good in C++. But just make sure that you choose one programming language that will suit you and that will be easy for you to flow with. Then you have to also be good in databases. That is that SQL that I mentioned earlier. So SQL and database work hand in hand as they help us to what? Save and retrieve data. They also support backup. That is sometimes you see Facebook is offering, do you want to back up your files? Do you want to back up your messages? Whenever you guys back up your messages and you wonder where are all my messages going to, that whenever I want to retrieve them from that backup place, I used to see them. It is being saved in the databases. Then the framework and library, you have to be good in React, you have to be good in Angular. All these are framework. They're not really a programming language, but they are framework in order to make your work look attractive and very nice. So looking at my diagram here, we have web design and development. If you study this course well, you are a good web designer and a good web developer. You can successfully create a responsive web design. You can create web development using this sign that you're seeing, this symbol that you're seeing here simplifies HTML. So you can do web development, you can do CMS websites, you can do e-commerce solution, you can do a lot of things. You can create a lot of websites, do a lot of things, but just make sure in everything you do you stand out, be the best in whatever you do. Moving on to the next slide. Career paths in programming. I'm sure a lot of you have been so excited about this programming of a thing, and I'm sure you have the question in your mind, okay, what do I stand to get if I study programming? What will I achieve? Will I be successful if I study programming? Yes. Career paths in programming. You can be a software engineers. These are the people that technically they create, they maintain our softwares. All the softwares that's in your system, they create it and they maintain it. You can be a software engineer, you can be a web developer, you can develop a full stack website, you can be the one to do the front end, you can do the back end yourself, you can be a web developer, you can be a mobile app developer developing apps for mobile phones, you can be a data scientist. These are the people that create algorithms to forecast outputs. Yes, this you can be a data analyst. These are the people that gathers data. They gather data, they study data to solve problem and lots more. There's so many career opportunities in programming. Just to mention a few is what I did here. You can also be a computer scientist, you can be a cyber securist, you can be an infotech, information and technologist. Yes, those are career parts in programming. So getting started, firstly, what I'll have to tell you is keep calm and carry on programming. So what are you going to do to get started? Firstly, like I said earlier, choose a programming language. Do you want to go with Python? Do you want to go with C++? Do you want to go with C#? Which one do you want to go? Choose a programming language that is suited for you, that is for you alone. So install a text editor or an IDE. I've explained that earlier. Either you use a notepad or you use an IDE. Practice good coding exercise, not the one that you would code today, next 3 years you not code again, next 3 weeks you not code again. No, practice good coding exercise. Try to code every day. A person that codes 1 hour every day is very much preferred and is very much better than a person that codes 10 hours 1 day in 3 weeks. So it is better for us to practice it every day than to do 1 day in 3 weeks. Then also, as you are learning programming, try to get some exercises that would help you, that will guide you. Like W3 schools, if you're learning from them, there are guiding exercises that they will give to you. So try to get some exercises, try to give yourself some projects, try to give yourself some assignments to do and a particular deadline to see how fast you've become and how your coding career is going on. So join online communities. This would really help you, because online communities, they will teach you, they will help you, I think they tend to set questions, they give assignments, they give projects, and that alone will be like taking one of the greatest step in your coding career. So moving on to the next slide, we have conclusion. So as we conclude on today's program, all I have to say in summary is programming is a rewarding and a challenging field. Don't think programming is a bed of roses, that all your programs must not have error. It's a lie. It have to have error, so that error will be the one to teach you, be the one to tell you that okay, next time you're not supposed to put comma here, you're not supposed to put full stop here. It will help you, to guide you. Just know that whenever you see your desired output, you'll be very glad, and whenever it comes out with an error message, do well to try and debug it. And I promise you, you would really enjoy programming. It's not just about the rewarding part, it also have challenging parts. So call to action today is for you to start learning to code today. You can start with HTML, you can start with CSS, but just start something. Start learning how to code today. And if you look at my diagram here, is a word of encouragement for you all. It says every accomplishment starts with a decision to try. Don't just say, okay, I've listened to instructor Ella, I'll do that later. No, you have to make the decision to start trying. So start to learn how to code today. Moving on to the next slide, we have our additional resources. These additional resources, I made this slide specially for you people so that you guys can see where else to get more ideas about this programming thing. So we have some online resources. Online resources, you can get more ideas from programming through Code Academy and through Coursera. Then for books, for those of you that like to read book, you can go to a bookshop and go and try to get Code Complete and Clean Code. Those books are very good and it will help you in your programming career. Then we have online communities like GitHub and Stack Overflow. So with these additional resources, I promise you will take a gigantic step towards your breakthrough in programming. I hope to see you next time, and I hope we all make the decision to try. I want to give God the glory for the successful section. I want to thank God for all of you that have listened today. I pray that the word that I've entered into you guys, the word that I've been taught to you guys, no devourer will come and take it away from you in Jesus' name. See you all later in my next video. Stay tuned, stay connected. Thank you.